Good morning, everyone. So the topic of today's NoSQL video assignment is a comparative analysis of key valued, documented, column-oriented, and graph database. I will be Abhimanyu Pal presenting for today's session. My USN is 1V20CS001. On moving to the introduction part of our assignment, here introducing to different types of database. Here, in the realm of data management, diverse database models such as key valued, document, object oriented, graph database played crucial roles, as we can see in the figure. Here, the second point contains this comparative analysis derives into the distinct features and applications of each database types, shedding light on their strength and weakness in their various use cases. Secondly, we are moving forward for the key value database. Here we are defining the definition and the characteristics of it. So here, the key value database stores data as key value pairs, offering simplicity and flexibility for high speed storage and retrieval. They excel in scenarios requesting fast access to simple data structures but may not be ideal for complex relationship or queries. Example here includes Redis and Apache's Cascade, making them suitable for catching seasons management and real-time analysis. Here we can have the example over here where we have the key as name and value has been Harry and so on. On moving to the next slide, we are having document database overview and use cases. Here, the document database stores data in flexible document type structure such as Johnson and or XML, making them suitable for complex and unstructured data. They offer rich query capability and schema, flexible but may face challenges in maintaining data integrity and scalability. Here, common examples include MongoDB, Couchbase, ideal for content management and real-time analytics and personalization. Here we have the example for the document type. Here in the field of the view we have the ID, key and quality. So it contains the document. The collection of documents contains the collections and the collections contains the database. Here it is all an instance oriented, that is primary. So on moving towards the fourth part of the uh, presentation, here we are having column oriented database features and benefits. So here column oriented database is in column rather than rows, enabling efficient database retrieval and processing for analytic workload. They are optimized for reading heavy operations such as query specific columns or aggregations across large database. Column examples include Apache's Cascade and Google Bigtable. They are ideal for data warehousing, business intelligence, and time series analysis. Here is an example for the column oriented. Here we can see the row storage where it contains ID, name, city, country, order number. It is easy to record or modify a record as in record. Might ready in unnecessary data. And here in column storage we are having ID, name, city, country, order name. Here the plus point is only need to read in relevant data, but the minus point over here, that is the drawback over here, is Drupal writes queries multiple accesses. On moving to the sixth slide, here we are having graph database, which we are gonna explain about the advantages and their applications. So, graph database stores data in nodes and edges, offering a flexible data model for interconnected relationships and complex queries. They excel in handling highly connected data, making them ideal for social networks, recommendation engine, fraud detection, and network analysis. Here, the popular graph database includes Node.js and Amazon Neptune. We can see over here. Here is an example of a graph database. It is like a hierarchical database. So we can see the people section where it can be human resource, finance, customer care service, operations, and the application contains the web page, the storage system, and here in infrastructure it contains networks, that is the data centers, servers, databases, and in process we are containing managed risks, managed strategic initiatives, increase revenue. That's all the processing part over here. So moving to the seventh slide of our assignment. Here it is a comparative analysis of four types: Key value database storage is simple key value format, making them efficient for quick lookup but limited in complex queries. Secondly, the document database stores data in Johnson-like documents, offering flexibility in data structure but potentially slower query performance. Thirdly, column-oriented database storage is in column rather than rows, optimizing for analytical queries but may be less efficient for transition operations, which can be in real time. So, fourthly, we are going for graph database excels in handling integrated data and complex queries, making them ideal for applications requiring deep relationship analysis. On moving towards the eighth slide of our assignment, here we compare the performance, scalability, and flexibility comparison. Here, performance, scalability, and flexibility are the key consideration when comparing different database types. Here, each type excels in specific area like key value for quick lookups, document for flexible data structure, column oriented for analytical queries, and graph for complex relationships. Here, thirdly, understanding these strengths and limitations will guide us in selecting the most suitable database for your specific application needs. On moving towards the second last slide of our assignment, here the use cases and real world examples can be shown. So use cases and real example key value database like Redis are ideal for catching, season management, and real time analysis. Document database such as MongoDB are great for content management system and e-commerce platform. Thirdly, the column oriented database like Apache, Cascade, and well suited for time series data and large scale analytics. Graph database like Node.js excels in social networks, fraud detection, and recommendation engine. Fourthly and lastly, understanding these use cases will help us in informed decision making in selecting the right database for our project. Thank you.